So we log in into our browser and then type in the IP address of our ESP32. Now the web page will load. Then we try to control our robot car. Then let's try to make it move. And then adjust the speed settings. Make it a little bit slower. Then make it a little bit faster. And that's it.
Hi, welcome to Donsky Tech. My name is Donsky and I'm back with a new project that I would like to share. In this post, I'm going to show how I created my own ESP32 robot car using Websockets. Websockets is a full duplex communication protocol over a single TCP connection, making it ideal to control our robot car with minimal delay due to latency. I have used PlatformIO IDE in developing this project as it simplifies the development of Internet of Things project due to the numerous code assist features. We're going to control our robot car using our mobile phones. I have ported the following D-pad and O-pad controller to make it suitable to controlling the movement of our ESP32 robot car. Before we move forward, let's discuss a little bit what WebSockets is. WebSocket is a communication protocol between a web server and a client like browsers. But other clients can be used like Python or C++ clients. In this post, we're going to use the JavaScript in programming our client. The WebSocket server publishes an endpoint that the WebSocket clients can connect. Typically, the endpoint is at this format. The client initiates a connection, and when a connection is established, then communication can start. But unlike HTTP, WebSocket supports bidirectional full duplex sending and receiving of messages. So both client and server can send messages between each other. We can also have multiple clients, but that is beyond the scope of this post. So, why use WebSocket? WebSocket is ideal for this type of Internet of Things application. It's because of the less latency offered by our WebSockets. So, if a message is sent from our mobile phone that the car should stop, then it should stop real time, else it would crash. As mentioned before, WebSocket supports full duplex bidirectional communication where messages are sent back and forth between server and clients. But in this project, we are not going to use it as messages are sent back from our client only and our ESP32 microcontroller responds to it only. There are other options that we can use like using Bluetooth or XML HTTP requests, AJAX, or long polling, but that is beyond the scope of this post. So, why build a robot car? Because building a robot car is cool, period. And it's way cooler if we're going to use our ESP32 MCU as our WebSocket server because of its built-in Wi-Fi capability feature. We have different options to control our robot car, like using Bluetooth or web server or other technologies like AJAX. But using WebSocket is a preferred option due to the almost real-time response and the possibility of duplex communication between our robot car and our controller. In enterprise applications, WebSockets is often used in chat application or streaming dashboard due to its nature of two-way bidirectional message exchange between a server and a web browser. In this phone, we're going to use our mobile phone browser to control the direction of our car and the speed of how it moves also. So, in this diagram, the ESP32 acts as our WebSocket server. The browser in our mobile phone acts as the WebSocket client. WebSocket's messages coming from our browser is processed by our ESP32 microcontroller. It then sends control messages into our LM298 motor driver to control the rotation of our robot car wheels. In addition to the direction controls, we're going to control also the speed of our robot car by using PWM or pulse width modulation. Whenever we click the touch, up, down, left or right arrow, then a WebSocket message is sent to our robot car and the ESP32 will control the direction. The speed settings like slow, normal, or fast controls the speed on how our robot car moves. So, what does WebSocket messages looks like? In this image, you would see that when I click the direction button, then we are sending a WebSocket messages through JavaScript. Note that this is not the actual WebSocket messages, but just console logs. So when we click something and stop clicking, then two messages are sent to the ESP32 WebSocket server. You can see these messages by clicking the console logs of your browser to be able to see what is being sent and received back from our WebSocket server. So, why use PlatformIO? I started exploring Internet of Things using Arduino IDE. But I have a bit of a problem using it if you are going to use it in serious development. First of all, Arduino IDE does not have IntelliSense support. So it is much better if your code gets highlighted when something is wrong or have an autocomplete option. Also, in Arduino IDE, you have to manually configure all the libraries that you need. On the other hand, in PlatformIO IDE, you will just need to edit the platform.ini file and all libraries will be downloaded automatically for you. I have coded lots of program in C++, JavaScript, HTML, CSS in this ESP32 Robot Car project using WebSockets, and PlatformIO IDE really helped me code it faster because of its smart feature. Lastly, if your IoT project requires a lot of user interface, then you need to create pages using HTML, CSS, and JavaScript. Sadly, Arduino IDE fails in this category. So I highly suggest that you explore PlatformIO IDE in the future. I will create my own post on how to get started also with PlatformIO IDE. So, to follow along with this project, you just need to have the following parts and tools. An ESP32 microcontroller unit. I use a 30-pin ESP32 generic board here. You can find it in your local store or online. An LM298 motor driver to control the two wheels of our robot car and a robot car chassis. For the tools, you just need the battery pack to power our ESP32 and breadboard and connecting wires. So, let's discuss the schematic diagram of our project. This image is the schematic diagram of our ESP32 robot car using ESP WebSocket. The ESP32, the L298, and the TT motor gear should be connected according to the pin configurations in the table. Make sure that the grounds are connected accordingly. We use the same battery pack in powering our ESP32 MCU. So the B-in should be connected to it as well. But it's possible to have external power for both the ESP32 and LM298. For the robot car chassis, I just purchased a common robot car chassis in the internet. Just follow the direction on how to assemble it. Now, let's discuss what the whole project is all about. The whole project code is in my GitHub account and you can download or clone it, whatever suits you. You can either download the code as a zip file and unzip it in your local directory, or if you are familiar with Git, then you can clone it in your local directory. Open up your Visual Studio Code and make sure that PlatformIO extension is installed. In a new Visual Studio Code window also, you can either open folder or git clone my repository. I have already imported my project in here. So you can see that all the files are already imported in my Visual Studio Code. Let us walk through the important stuff in the code. The first thing to look into is the platform.ini file. This is where we declare the required libraries used by our project. We only need the following libraries: the ESP async tcp.git and the ESP async web server. We also set the board to ESP32 dev, and using the Arduino framework in development, Also, we set the monitor speed to 115/200. Now, let us subdivide the code to several sections as it will be hard to explain it in one go. We will need to code in the following languages. The D-pad and the O-pad controller are coded using HTML, CSS, and JavaScript, while the WebSocket server and the motor control is coded in C++ Arduino code. I have here my code pen, which I will show in the link in the description. For a complete demo on how I created my user interface, then look at the following code pen. I have shared my whole HTML, CSS, JavaScript setup at this code pen that I have forked also. Thanks to the guy who created this very nice D-pad and O-pad controller. First, we look at the HTML code. You need to be familiar on how to structure the user interface with HTML. We define our wrapper div and created option for controlling our speed settings like slow, normal, or fast. Next, we set up our controllers like the D-pad or the O-pad. These are just links that get styled using our cascading style sheet or CSS. I won't be discussing much about the CSS sections as this would need specialized discussion and this post would not be able to cover everything. I suggest you look into the internet for some information on how this works. The most important thing to look into at the HTML is the data-direction attribute, as we will be manipulating this in our JavaScript code. So as you can see, the data direction is either up or the data direction is right, down, or left. The good thing about CodePen is that whenever you do some changes here, it will automatically reflect back in the result set. Next, we look at our JavaScript code. The goal of this post is to use our mobile phones in controlling our robot car. So I created two functions to respond to event. One is the touch start handler and the touch end handler to respond to a click in the link of our controller. After which, we attach the two functions above to each of our links. Same also with the speed, after which we attach the two functions for each of the links. Same also as the speed settings, and we respond to changes in the speed settings also. As mentioned above, we're using the data direction attribute of the link and send those directions as WebSocket messages so that we can control the direction of our robot car. Now, before we move forward, let's discuss a little bit about each of the files in the data folder. Code that I have shown in the code pen serves as the baseline on how our D-pad and O-pad controller will work. However, that is not complete as we need a way to send messages to our ESP32 WebSocket server from our browser. In the data folder, there is a folder called CSS which contains our styles such as the main CSS and our custom CSS style sheet also. The JS folder contains our customs.js which we'll be using in creating our WebSocket client. Let's take a little bit look on how the index HTML is structured in our project. The index HTML contains the code for the user interface of our controller. This is almost similar to the code pen that I have shown above. The only major difference is that it contains the necessary links for our custom CSS and the custom.js in the head and the body section. The important thing that changes in this file is that there is what we call as template string. These are template string that are interpreted by the ESP32 asynchronous web server. I'll discuss more a little bit on how this works in the next section. Now, we go to our custom.js. The function of the custom.js is to initiate a WebSocket client and send messages to our WebSocket server. The onload function is called when our web page is loaded, and its job is to initialize a WebSocket from our browser to our ESP32 WebSocket server. The functions initialize socket, the onOpen, the onClose, and the onMessage, and the sendMessage command are used to log messages and going and coming from our WebSocket client. The important thing is the send message, which is the command that sends WebSocket messages to our ESP32 WebSocket server. A WebSocket message is also sent whenever we click the speed settings of our radio button. So in this case, as you can see, once we click the slow, normal, or fast, we send a message into our ESP32 WebSocket server. Lastly, the following function sends out the control to our robot car. So whenever we click the up, down, and left arrow, a message is sent to our WebSocket server. And that's it for the code for our OPAD or DPAD controller. Next, we go into our main.cpp file. If you look at my GitHub account, put several comments in here so that you would be able to see what happens in each line of code. So let's go to each line of code one by one. Before we proceed, we need to edit the following lines of code before we deploy this to our ESP32 microcontroller unit. Change this according to your Wi-Fi setup. So, put your SSID and your password in this part of the code. Next, the main.cpp includes the different header file. The code above contains the necessary include statement. The ESP async web server contains a WebSocket server that runs on the same port 80 of our web server without additional code. This line of code are enumeration that we assign for the speed settings. We are using PWM in ESP32 and we have set the resolution to 8-bit. So the value is between 0 to 255. These values are the assigned values that we set to the duty cycle of our PWM pin. So, if we set the PWM pin to 255, then our car will run at full speed. Next is the important part class. We have declared a C++ class to represent our car and is being used in object-oriented programming per se. Think of a class as a blueprint of a housing unit. We can use the class to create several houses using the same blueprint. Also, we can hide all the functionality in this object so that our code will be easier to read. The private marker means that the following attributes are only accessible from this class. We have defined several pin connections here, including the frequency, the channel, and the resolution for the PWM pin of our robot car. Controlling the enable pin, ENA and ENB of LM298 through the PWM will slow down or speed up our car. Next, we discuss anything which has a public marker. This line of code is called a constructor in our car object. It's being called when our car is first created. In this part of the code, we initialize the necessary pins for the pin mode and set up the PWM settings of our ENA and ENB pins of our L298 motor drivable module. Also, we have initialized the speed settings to normal. Next, we have here the different function where it will discuss how our robot car will work. There's a function called turn left, turn right, move forward, or move backward. Think of it like this. We have created a new data type or structure in C++ that is customized for our car object. A car object can move forward or turn left or right, and even can move backward. We have set the movement of our motor in each of the following methods, and we are able to set the speed of our car using the set current speed and able to get the current speed of our existing car. When we click the up button in our mobile phone, then we are all going to call the car that move forward, and if we stop clicking, then we call the car that stop. Think of how much better we have arranged our code this way rather than creating multiple unrelated functions. So, if you can see in this line of code, we have created our car or initialized our car object. After which, this line of code is where we have defined our asynchronous web server and asynchronous web sockets. running on the same port, which is port 8. So this function is used to send commands to our car. The command comes from the Websocket messages coming from our Websocket clients running in our browser. As I have mentioned above, whatever socket messages we receive, then we just forward it to our robot car object. So as you can see in here, if I receive a left command, then we'll just call the car.turnLeft command. Next is this index page processor function, which, as I have mentioned in the index.html page, processes our template. So if the current setting that we set is slow, then it will return a check command or attribute. What will happen is that our option radio button in our HTML will be selected as checked. Next, we have this callback function that receives messages from our WebSocket client. There are several message types that we are going to receive from our WebSocket client, such as the connect, disconnect, or data. The thing that we are more interested is in the event data. In the event data, we extract the value that was sent by our WebSocket client. And then after getting the message such as up, down, left, or right, we call the function that we have created called sendCar command. Next, we have a function called notFound, which is just a function that gets called if we access our web server with a resource that is not present. Then the next function is called the setup, which everybody is familiar with Arduino programming. We initialize the serial monitor and the baud rate. Then we start connecting to our Wi-Fi. Next, we initialize SPIFFS, which is the file system being used by the ESP32. So all of our data files like the HTML, CSS, and JavaScript are loaded from the SPIFFS. This one is called our callback function to our WebSocket server. So in any event that messages are sent or received, they are being called. The function on WS event is being called. Then these are called routes in our web server so that we are able to load the CSS and JavaScript from our file. And then lastly, we have here the start server, which starts our server. Notice that in the loop command, there's no code in here as the server is running in asynchronous mode. That's all how the code works. Once you are done wiring your robot car and following the schematic diagram that I have created, the next thing is to deploy our ESP32 Robot Car program to our ESP32 microcontroller. To do that, just click this PlatformIO extension and first click the upload file system image. When we click this upload file system image, whatever is in the data folder is being uploaded into the ESP32 file system. In the event that you are encountering problems like the ESP32 having some connect problems, then just click the boot button during the uploading process. After which, the next thing that we need to do is to click the upload and monitor project task. In this project task, what will it do is that it will upload our program, which is mainly the main.cpp, into the ESP32 file system also. And then it will open up a terminal in here so that we'll be able to see the commands that are being sent and received from our robot car. In the event that you encounter problems like Wi-Fi failed, just click the reset button in the ESP32 and you will be able to refresh the connection to your ESP32 robot car. And then what you can do next is just open up your web browser in your mobile phones and then just click the IP address that will be assigned by your network. And you are able now to control your robot car. And that's it. Happy exploring! In this video, I have shown how you can control your robot car using ESP32 and WebSockets. Please support my page by subscribing to my social media channels and consider sharing it to your friends. Until then, happy exploring!